Hey guys, welcome back to Math from my desk. It's been quite a while since my last video. I've been a bit busy with schoolwork and stuff, but anyways, we are back, and in this video we'll be solving this limit right here with L'Hopital's rule. So we have the limit as x approaches 0 of the natural log of 1 plus x minus x all over x squared. So if we go ahead and use direct substitution for this, what we would get is the natural log of 1 plus 0 minus 0 over 0 squared. So that gives us the natural log of 1 minus 0 over 0. The natural log of 1, this right here is just 0. So you end up with 0 minus 0, and this is an indeterminate form. And so what that tells us is that we will go ahead and use L'Hopital's rule, LHR. And this says that the limit is x approaches 0 of the natural log of 1 plus x minus x over x squared. This is equal to the limit as x approaches 0 of the derivative with respect to x of the natural log of 1 plus x minus x all over the derivative with respect to x of x squared. And so we treat this as a new limit now. So what we have, we have the limit as x approaches 0 of, let's go ahead and evaluate this derivative. So the derivative of the natural log of 1 plus x, this means that we're going to have to use the chain rule. So what we have is 1 over 1 plus x, because the derivative of the natural log of u is 1 over u. So we have 1 over 1 plus x multiplied by the derivative of 1 plus x, which is simply 1. So we simply end up with 1 over 1 plus x minus the derivative of x, which is 1. So we have in the numerator is 1 over 1 plus x minus 1. And in the denominator, the derivative with respect to x of x squared, that is simply 2x. So now we can go ahead and use direct substitution once again. So if we do that, what we have is 1 over 1 plus 0 minus 1 over 2 times 0. And so that gives us 1 over 1, which is 1, minus 1 over 0. And once again, this is an indeterminate form of 0 over 0. So that tells us that we're going to use L'Hopital's rule a second time. Yes, you can do that, L'Hopital's rule. If you use it once and you get an indeterminate form once again, then you can use it a second time. And same thing, if the second time you get an indeterminate form, you can use it a third time. In fact, in IB exams and AP exams, this is most often what you will get for L'Hopital's rule. So now we're going to go ahead and take the limit as x approaches 0 of 1 over 1 plus x minus 1 over 2x. That is going to be equal to the limit as x approaches 0 of the derivative with respect to x of 1 over 1 plus x minus 1 divided by the derivative with respect to x of 2x. So if we evaluate this derivative that's in the denominator, that of 1 over 1 plus x minus 1, the derivative of 1 over 1 plus x, we can treat this as 1 plus x to the power of negative 1. So we can use the power rule and the chain rule. We have negative 1 plus x to the power of negative 2 multiplied by the derivative of 1 plus x, that is just 1. So we have negative 1 plus x to the power of negative 2, which is simply negative 1 over 1 plus x squared. And then the derivative of negative 1, that is just 0. So we have the limit as x approaches 0 of negative 1 over 1 plus x squared. And then we're dividing by the derivative with respect to x of 2x, which is just 2. So now this right here is our new limit. This is supposed to be a 1. It looks like a 7. And now we evaluate this using direct substitution. So what we have is negative 1 divided by 1 plus 0 squared. Sorry, here I put 1 plus x squared, but the squared is supposed to be out of the parentheses. So we have negative 1 over 1 plus 0 squared all over 2. This gives us negative 1 over 1 squared, which is 1, over 2, which is negative 1 over 2. And this right here is the final answer to our integral. Thank you guys for watching. Please like and subscribe, and I'll see you soon for another video.